Yes, Mafaz, am I audible to you? I think, Mafaz, you have muted yourself, or can you hear me? Am I audible to you? Yes, Mafaz.
Yes, sir.
Yeah, my voice was not coming to you.
It was not, but now it is coming.
All right, all right. Okay. So, in our previous class, we begin with the new chapter, right? So, the chapter was basically motion and time, right? So in this chapter, we so far we talked about types of motion like the uniform and non-uniform motion, right? And we also talked about speed and time. Okay, so let's quickly revise the concepts, and then we will talk about in today's class. With we will begin with new concepts in today's class. Then, all right. Okay, so we talked about motion, right? So when do we call a body to be in motion, Mafaz?
Then when it is moving,
When it is moving. Okay, but how do we identify the motion of a body? Like you are like the earth is in motion, you, me, and everyone is present on earth. The earth is in motion, but are we in motion in respect to earth? Because we are sitting on earth or standing on earth, the earth is doing rotation. Okay, it is rotating. So, what do you say about yourself, about me, and rest of the objects present on the surface of Earth? Are they in motion, or are they in stationary position in respect to Earth? Yeah, Mafaz?
in motion.
No, we in respect to Earth are in stationary position, while Earth is moving. But we are right now, if you consider your position and mine position, we are at a stationary position. Okay, because let's say the class is for an hour, and you and me, we both are going to be sitting at the same position, right, Prakash? So hence, with respect to time, even 1 hour passes, our position with respect to time is going to be same here, isn't it, Mafaz?
Yes, sir.
Exactly. So motion, when you define it, you need to consider about about time as well. Okay. So an object is said to be in motion if it changes its position with respect to time. For example, a car moving on a road, with the passing time, the car is also changing its position. Right. Okay. Now, in your previous class, and what about the object at rest? If the body is not changing its position with respect to time, then the body is said to be in rest position. For example, you are sitting on your chair continuously for 1 hour. So your position is at rest because the time kept on passing, but your position remained same. Okay, so in your previous class, you must have studied about different types of motion. Okay, like they are rectilinear motion, they are circular motion, they are rotational motion, they are periodic motion, right, Mafaz?
Yes.
So if a body is moving in a straight line, you say that it is doing a rectilinear motion, or it is also called as translatory motion. So when a body is moving in a straight line without changing its direction, then the body is said to possess translatory or rectilinear motion. For example, a car is moving on a straight line or a person running on a straight pathway, that will be called as rectilinear motion. Similarly, some bodies perform circular motion, right? So for example, Earth moves around the sun in a circular path, in a circular orbit. The Earth is moving around the sun in a circular orbit. This is the circular orbit of Earth moving around the sun. All right, Mafaz. So the motion that is here, what we are talking about, revolution of the Earth. So the revolution of Earth around the sun, that is example of a circular motion. Or for examples, children who play in a merry-go-round, or motion of pedals of a bicycle. These are examples of all circulatory motions or circular motion. Now you have got periodic motion. What is the periodic motion?
Well, when an object comes back to its place in a fixed period of time.
Yeah, that can be considered a periodic motion. Or in a periodic motion, now, as you will observe that the object after an interval of time, it will repeat same type of motion. So the motion will be repeating itself after a interval of time. So that will be called as periodic motion. Like example of a what? Example of a pendulum. Okay. Or see if you see a electric bell. Have you seen an electric bell? So the motion of the hammer in the electric bell, that is also, and that will also be an example of a periodic motion. So how does an electric bulb looks? It looks something like this. See, this is your electric bell and it is being hammered by a something, right? It is attached to this bell and it keeps on hammering it. It keeps on hammering it. So that motion is also example of a periodic motion. All right. Okay. What are some other examples? To and fro motion of a simple pendulum, that will also be considered example of a what? Yeah, example of a periodic or oscillatory motion. Okay. So we also talked about time and a speed. Okay, speed, that is the average speed. Okay. So speed is nothing but the total distance traveled by the object in a given unit period of time. Okay. So how do we represent it? We calculate it simply by dividing distance by time. Okay, that is how you get the speed. And the unit of speed is generally measured in two units, units. One is meter per second and the another one is kilometer per hour. All right, Mufaz.
Yes.
Okay. So speed of an object is simply the distance traveled by the object in a given unit time. Okay. So let's say a car is traveling, a car travels 100 kilometer in 4 hours. A car travels 100 kilometer in 4 hours. What is the speed of the car?
Um, um, 25 kilometer per hour.
25 kilometer per hour. Very good. 25 kilometer per hour. Now, if someone asks you to convert this unit in meter per second, how do we do that? We do it like this. It is 25 kilometer per hour.
25,000 kilometers.
Exactly, 25,000. Then 1 hour, it will be converted into minute first, then into second. So like this, we can find out the unit. Or you can simply write it like this. If you are provided with any given speed in kilometer per hour, to convert it into meter per second, what we can simply do? We can simply multiply the given value by 5 upon 18. Let's see how we are doing this. See here, like 25 kilometer per hour. Okay, let's convert this kilometer per hour in meter per second. So to convert kilometer in meter, we simply multiply it by 1000, and hour to convert into second, we first multiply it with 60, then again with 60 to convert that minute into second. So what value you are going to get here? 1000 upon 3600. Simplify this further, Mafaz. What is the value? 1000 upon 3600. What does it gives you?
Uh,
First, cancel the two zeros, these two zeros. So you are left with 10 upon 36. No. Simplify it further, 10 upon 36. This one was simplified 10 upon 36. 5 by 18. Very good. So we get 5 by 18 here. All right. So we can conclude from here that to convert a given a speed from kilometer per hour to meter per second, we can simply multiply it with 5 by 18. So note here, to convert a speed from kilometer per hour to meter per second, we will multiply it with how much?
5 by 18.
Exactly. 5 upon 18. All right. Okay, now moving on, we talked about how we observe the speed. Like in this figure, you can observe here that the position of the vehicles are changing here after a given period of time. This green vehicle has moved forward. The black vehicle given here has, in fact, vanished from the figure here. It has moved even further. Okay, so position of the vehicles is changing here. It shows that with time, the position of the vehicles are changing in the given figure here. Okay, we also talked about uniform and non-uniform motion. Okay, now, what is the basic difference between the two types of motion?
So uniform motion goes in a straight line.
Yeah.
Non-uniform.
In uniform motion, speed remains same. Okay, the speed of the body is going to be constant, right? So when an object moves along a straight line with a constant speed, then the object is said to be in a uniform motion. All right. So an example is a car moving in a straight line. And what about non-uniform motion?
So when a car changes its
Speed and direction as well. Okay. So if the body changes its speed with respect to time, and if it also changes its direction, then that type of motion will be called as non-uniform motion. For example, the motion of a train here. Okay, it is not very, like at the beginning of the journey, it starts slow. Okay. And in the middle of the journey, it runs fast. Okay. And while the train is about to stop, it again becomes slow. So you see the speed keeps on changing. Okay. And in fact, the direction also keeps on changing. Okay. Now, before we move on, let's quickly solve few questions. All right. Let's solve few questions related to time, speed, and distance. Okay. So read this one first, then we will solve few questions. Measurement of time.
measurement of time. A duration or moment in which things occur is known as time. With the help of clocks and watches, we generally measure time. It is very difficult to think that how did the people in ancient time measure times as they did not have clocks or watches.
Yeah. Okay. You see, earlier, earlier people used to have different traditional methods of measuring time. We will come to that discussion. Just let's solve few questions related to time, distance, and speed. So we know that speed equals to what? Distance upon time.
Yes.
Okay. Now from this formula, we can calculate distance and time also. This is the formula to calculate the speed. Okay. Now if we make some changes in this, we can in fact calculate distance and time from this as well. Like we can write time equals to distance upon speed. Isn't it so much as? We can write it like this. Or you can also write it like this: distance equals to time multiplied speed. Okay, because if you are transposing this time from here, this time you transpose it to here. So here it isn't, this time here, it is in division with distance. So if you transpose it to left side, it will go into multiplication with the speed. So distance can be also calculated like this. Okay. So just for the moment, you do one thing, that you remember these three formulas. Okay. What are the formulas? Speed equals to distance upon time. Time equals to distance upon speed. And distance equals to what?
Time, time multiplied by speed.
Time multiplied by speed. Okay. Just remember these, or do one thing, write these three in your copies, because we are going to solve few numericals and you will be needing these formulas for that. Okay, quickly write these three formulas in your copy. Yes, Mufas, do tell me when you are done.
Done, sir.
Okay. Okay, let's solve a question here. Okay. So the question is, yes. Mm, yeah. So your question is, a man rides a bike with a um, man rides a bike. Yes. A man is riding a bike on a road at a speed of 50 meter per second. If the distance of the road is 100 meter, find the time taken. Find the time taken to cover this distance. Okay, what does the question says here? A man is riding a bike on a road at a speed of 50 meter per second. All right. And if the distance is 100 meter, find out the time taken to cover this distance. Yes, pretty simple question, Mafaz. Solve this one. Yes, Mafaz. Which formula we have to use in this one?
Time is equal to distance upon speed.
Exactly, exactly.
So the 2 minutes.
Two, not in minutes. It is supposed to be in second. Okay. So we have provided with in the question it is given what is the speed? It is 50 meter per second, right? And what is the distance? 100 meter. And we know, what do we know? That time equals to distance upon speed, right? So it is 100 meter upon 50 meter per second. Okay. So 100 meter upon 100 meter upon 50 meter per second, it means 100 meter 50 upon second. 50 meter per second. 50 meter per second can be written like this. 50 meter upon second. Per
Yes.
means what? It is division sign here. So can we not write it like this? 100 meter. Okay. Into second. This second will come on the numerator side. And here you are left with this 50 meter. Getting this one, Mafaz. Did you got this step?
Yes, sir.
Okay. Like if you have written provided with a value like this, AB upon C upon D. Okay. There are two fractions here, A upon B and C upon D, and both of them are in division here. So we can write it like this, A upon B multiplied D upon C. Okay. So same thing we have done here. It is like this, 100 meter. Okay. And it is being divided by 50 meter per second. Okay. So 100 meter, we can write it like this, 100 meter upon 1 divided by 50 meter per second. So 50 meter upon second, right, Mufas?
Yes, sir.
So see, we can write it in this form, A upon B multiplied D upon C. So it will be 100 meter multiplied second upon 50 meter. Any confusion so far?
Mm,
If you have any confusion, I can explain this again.
no, sir.
Okay, very good. So meter gets cancelled. It is 2. So it is from here 2 second. So that is the required answer. Okay. Since the speed, it obvious it is not going to be a minute from the fact that it shows that 50 meter per second is the speed. So time will also be calculated in second. Okay. Now solve one more question. Okay. Okay. Now the question is, the odometer of a car, it reads 57,300. Let me write the question here. Okay. Question says that the odometer of a car reads, you know what is odometer? We discussed this in previous class that odometer shows what? It shows the
Distance.
distance traveled by the vehicle, right?
Yes, sir.
So the reading on given odometer is 57,321.0 kilometer. Okay. So when the clock shows the time 8:30 a.m. So when the clock was when the timing in the clock was 8:30 a.m., this was the distance traveled by the car here. Okay. Now do tell me what is the distance? Can you read the question properly?
Yes, sir.
Yeah. What is the distance moved by the car if at 8:50 a.m. the odometer reading has changed to 57,336 kilometer? Okay. So there are two things you need to find in this question. First, you need to calculate the, first you need to find out the distance. Okay, first calculate the distance traveled by the car. Okay, then next you need to travel the speed of the car. Okay, my first speed of the car in kilometer per minute. Okay, not in hour. Okay, so these are the two things you need to find in this question. The odometer shows 57,321 kilometer when the time was 8:30 am. Then at 8:50, the odometer changed its reading to 57,336 kilometer. So we can clearly find the distance from here, Mafaz.
Yes.
Okay. Then once you have find out the distance, then you will need to find the speed of the car. And you can calculate the time here also. It is pretty simple.
The 20 minutes.
Time is 20 minutes. Very good. Yes, Mafaz. What is the distance traveled?
For 15 kilometers.
15 kilometer. Okay. So distance you have find out. It is 15 kilometer. Now find the speed. Just Mafaz. Got the value?
No, sir.
Okay. Which formula we are going to use here? First one, second, or third?
The first one and the no, sir, the first one.
Only first one. Okay. Okay, shall I help? Will you be able to solve it or shall I help you?
I will be able to solve it.
Okay, okay, take your time then. Saturdays are off in your school or you go to school on Saturdays as well?
Mm. So Friday, Saturday, my weekends.
Okay, okay.
So 750 meters per minute.
760?
Wait, sir. So
Yes,
the 0.750 kilometer per minute.
exactly, exactly. Very good. 0.75 kilometer per minute. Very good. Okay, that is or 3.4 kilometer per minute. Very good, fast. Okay, so let's move ahead then. Okay, so we were talking about measurement of time. So earlier people had different methods of measuring time since watch was not discovered then, right? So in order to measure the time, ancient people used some natural events which repeated regularly. The most primitive method was seeing the sunset of the seeing the sunrise. Okay, so from first sunrise to next sunrise, it's constituted one whole day. So that is how they had idea of they had an idea. They got the idea that one day is from one sunrise to another sunrise. Okay, so this is how they got the idea of 24 hour. Okay, so from one sunrise to another sunrise, they got the idea that this constitutes a or this constitutes a day. Then they discovered several traditional tools to measure the time, which part of the day is showing which time. So first one was the sundial here. So how does a sundial measures time? How does it shows time? It shows time by the position of the shadow of the sun. Okay, so the shadow which falls on the number shows the time of the time in a given day. Then you had a device which used sand to calculate time. Okay, so this sand was used to measure short span of time, right?
Yes, sir.
So device it used the flow of sand from one glass bulb to another in order to measure time, and hence it is called as sand clock. Then you had this water clock here. Okay, so water clock, which what principle works here? It basically works on the principle that the rate at which water drips from this hole into the container below it, into the container below it. So the time this container takes to fill or the rate at which the upper container empties, that will show the different time here. Okay, so you see if you pay a close attention here, pay a close look here. See, it is divided into total 12 levels here. Okay, 12 levels. It has been divided into 12 levels. See, first level, second level, third level, fourth level, and so on. So the time, the rate at which each label gets emptied, that will show the time here. Okay, so this is how different traditional methods were used for measuring time. Okay, now later on we discovered pendulum and with better modification we made some electric watches. Okay, so what does a simple pendulum works on? If you were to see the structure of a simple pendulum, it has got a bulb attached to a thread. So there's a small metal ball called bob here, okay, which is suspended by a long thread from a rigid position. So see this figure here. From a rigid support, a long thread attached to a metal ball called bob is shown here. That is simply a simple pendulum here. So simple pendulum which will show you which type of motion, rectilinear, circulatory, or oscillatory motion? That is a periodic motion.
The oscillatory motion.
That will show you oscillatory motion. Okay, so how does it work? It is suspended by a long thread from rigid support such that bob is free to swing back and forth. So this bob is free to swing back and forth. Okay. So who discovered this type of motion first? It was Galileo. He was the first person to study the motion of a pendulum. All right. So what happens in here, if you see second figure here, see second figure here, this pendulum, it will oscillate from its mean position to its extreme position and come back to its mean position again. Like see, the different positions are shown here. Position D, F, and E are shown here. So from position F, it will move to position D. So and again from position D, it will move to position E, and again it will come back to its initial position, that is position F. So when a pendulum performs such type of motion where it goes from position F to position D first, and then from D it goes to position E, and then again comes back to its rest position, that is mean position, that is F here. So that one complete motion is called one oscillation. Did you get this, Mafaz?
Yes, sir.
Okay, yeah. Can you explain this to me? What does one or one complete motion of a pendulum is called, and what does it constitute?
So when the mean position of the pendulum goes to the extreme position of the right side or the left side,
Yeah,
and then it goes back to the extreme position of the other side,
yeah,
and then comes back to the mean position.
mean position. Then it completes one complete set of motion, that is called one oscillation. All right. And the time taken to complete one oscillation is called time period of the pendulum. Right. Time period. So how do we define this time period? Time taken to complete one complete oscillation is called time period of the pendulum. Time taken to complete one oscillation. Okay. So suppose I say you that I have got a string here. Okay. Its length is 100 centimeter. I have attached a bob here. And to complete one oscillation, here we need to find its time period. Okay, so how do we calculate time period of a simple pendulum? So say here, time taken for 20 oscillations is how much? 42 seconds here. So if this pendulum does 20 oscillations, the time taken is 42 seconds. But we know that time period is calculated for one oscillation only. The time taken to complete one oscillation. Okay, so how do we calculate this time period here? So it will be yes. So time period of the pendulum will be calculated like this. Total time taken, total time taken by number of oscillations. All right, Mafaz. So the total time taken, total time taken for 20 oscillations is how much given here?
So 42.
42. Okay. And the number of oscillation is 20 here. Right. The pendulum is doing 20 oscillations. Hence time period is how much? It is 2.1 second. That is the time taken by that pendulum to complete one oscillation. Let's say for 20 oscillations, this was your first reading. Okay, like let's say you are performing an experiment in the lab. Okay, for 20 oscillations, you find out that it took 42 seconds. Now, let's say if I say that I performed another experiment with the same pendulum. I let it oscillate 20 times. I calculated the time taken for it to perform 20 oscillations. In the another reading, I found that it took 40 seconds. Then what is the time period going to be here in another reading?
Sir, 2 seconds.
2 seconds. Very good. That is 40 upon 20. That is 2 seconds. So this is how you can simply calculate the time period of a simple pendulum. All right. And you need to know that the standard length of this string, now, it is 20 centimeter. Okay, that is the standard length of a string used in a watch that consists of pendulum. Okay. As I already told you that time taken by the pendulum to complete one oscillation is called its time period. Okay. And you will notice one important thing here. In fact, the time period of any pendulum will depend on the length of its string. Okay. So if you shorten the length of this string or if you increase the length of this string, it will have impact on its time period. All right, Mufaz.
Yes, sir.
So time period gets affected due to length of the string. Note this thing, right? Now, units of time. Okay. So what are the units of time? Time can be measured in second. Okay. It will be measured in minute. Okay. It will be measured in hour. Okay. We have got milliseconds also. Okay. But that we don't use in calculations. Okay. Majorly second, minute and hour will be used in the numerical problems you will be solving in this chapter. So are the units of time. Note this thing that nowadays now most of the clocks or watches which we use have an electric circuit with one or more cells, and these clocks are called what?
Quartz, bro.
Quartz clocks, right? So notice the clocks which we have got, whether they are analog or digital clocks, all of them have got an electric circuit attached to the back of their body. Okay, and there is a very small cell which runs that electric circuit. Now, we already discussed about how speed is measured. Okay, so using that formula, we can simply calculate the speed, and the function of a speedometer and an odometer, you already know that a speedometer measures the vehicle's speed at any given period of time, and odometer calculates the distance traveled by the body. Now, let's talk about the distance and time graph. Right, Mufaz? So, we can in fact represent distance, time, or speed of a body in a graph paper. So, how do we denote it? You see, first let's talk about what is a distance time graph actually. So, it is a graph which is plotted between the distance in the y-axis and time in the x-axis. So, the question comes here, so what is this y-axis and x-axis? First, you know about these axes here. Okay, so if you take a piece of graph paper, okay, and you draw horizontal and vertical lines on it, okay, and the line where they will be meeting, that will be called its center, or it will be called as origin point. Okay, now this line here, that is called a x-axis. Okay, my fast, and this one line is will be representing y-axis. Okay, so on the x-axis, what do we denote here? We will be denoting time on the x-axis, and on the y-axis, we will be denoting distance. Okay, so using this time and distance axis being represented on two different axes, we can actually find out the speed of the body. Okay, so the line running from its origin will give you the value of the speed of the body. Okay, so this graph is different for different type of motion. Yes, Mafaz, are you there?
Yes, sir.
Okay, so this graph will be different for different type of motion. Suppose if a body is doing a uniform motion, then its graph will be different. If a body is performing a non-uniform motion, then its graph is going to be different. So let's talk about different types of graph. Okay, so first is distance time graph for a uniform motion. Now you tell me, what is the speed in a uniform motion? Is it constant or it keeps changing? In a uniform motion, the speed keeps changing or it remains same? Yes, Mafaz,
Sir, it remains same.
it remains same. Okay, so when an object moves with a uniform speed, or we say constant speed, it travels equal distances in equal interval of time. Okay, so let's say 5 minutes, okay, 10 minutes, 15 minutes, and 20 minutes. Say I have got a car here. Okay, so for the first 5 minutes, the car traveled a distance of 50 kilometer. For the next 10 minutes, it again covered a distance of 50 kilometer. Then it covered a total distance of 100 kilometer. Then again, after 15 minutes, the car had traveled 150 kilometer. Then after 20 minutes, I found out that the car has traveled 200 kilometer. Now notice this thing here. Isn't the car traveling equal distances at equal interval of time?
Yes, sir.
Okay. See here. The time difference between these two distances here. It is 5 minutes. 10 minus 5, that is 5 minutes. Again here, 15 minus 10, that is 5 minutes. Then 20 minus 15, that is 5 minutes. What about the speed? Isn't the interval of speed or isn't the speed of isn't the interval of distance also same here, Mafaz?
Yes, sir.
Okay, so 50, 50, and 50. So if you were to represent it on a piece of paper, how would you represent this in a form of graph here? So you will take two axes, axis X and axis Y. This is your axis X and axis Y. They are basically horizontal and vertical lines which meet at a point that is called O, which is basically their origin. So say I represent time on this x-axis, right? So I am representing time here. So let's write the time: 5, 10, 15, and 20. On and the x-axis, what do we represent, Mafaz?
Sir, distance.
Distance. So what are the distances given in the figure here? It is 50, then 100, then 150, then 200. All right. Now let's match these values. Okay, let's draw it further here. So if you draw a line from 5 and if you draw a line from this 50 kilometer here, they will meet here, right, Mafaz? And again, you extend this line from 100 and a line from 10, they will meet here, right, Mafaz? Getting this thing. And again, you draw a line from 150 and draw a line from 15 also, they will meet here. And for 200 also they will be meeting here. So notice this thing here. If you were to draw a line from origin, yes, Mafaz, are you there?
Yes, sir.
Yeah, if you draw a line from origin, you will get a straight line passing through the intersection of distance and time graphs. Right, Mafaz? So this is a straight line here. Okay, so this straight line actually shows you a uniform speed. Okay, so we say that the distance time graph of an object moving with a uniform speed is a straight line. Okay, that is the conclusion about distance time graph for uniform speed. Got this, Mufaz?
Yes, sir.
Okay, so under 2 or 3 lines, explain the whole procedure to me, what we just did here.
Sir, when the distance and time meet at a given point, and then the origin goes on the straight line for in the
Yeah.
uniform speed.
Okay. The basic thing you need to fit in your mind here is that when an object is moving with a uniform speed, you see this, the object here is moving at a uniform speed. Okay. That means equal distances are traveled at equal interval of time. 50 kilometer, again 50 kilometer, again 50 kilometer for 5 minute, then again 5 minutes, then again 5 minutes. Equal interval of time as well as equal interval of distances are being traveled by the object. Hence, it has a constant speed. So when we will represent this in a graph paper, you will find that we get a straight line running from origin. Okay, so here we are basically matching when we drew lines from x-axis and y-axis, namely from time and distance, and when we joined them, so we saw that the straight line was running from origins, passing through all these points here, passing through all these points. So a straight line represents a uniform motion. Got this?
Yes, sir.
Okay. And when in tomorrow's class we will talk about non-uniform motion, we will see that the speed of the body keeps on changing at a different interval of time. Hence, their graph is